And we're live, and we're here with Paul and Gail Anderson.
Hello, everybody.
ASG Tech Software Group.
Yeah,
that's where you
teach.
Yeah,
That would be
yes.
us.
Okay, so known Paul, Gail for I don't know how many years. Crazy number.
Too many.
Fellow Java champions, obviously. Authors, trainers, Java proficientaries, and I guess we're going to talk about FX today, yeah?
Yes, we are.
Yes, we are.
And a fun little game that Gail has thrown together.
Yep, it's pretty fun. It's fun to do.
Gonna be fun to do. Okay, then I'm just gonna let you have at it and just say, yeah, let's go. Okay. Any rules for chat?
Thanks, Kirk.
See you then.
Okay, hey everybody, welcome to the Java Champions Conference where we are virtual everywhere. My name is Paul Anderson.
And my name is Gail Anderson.
And we are with the Anderson Software Group. This is our session today, Are You Game? Mobile Development with Modern Java, JavaFX, and GraalVM. Okay, so who are we? Gail and I are the co-founders of the Anderson Software Group, a software training company here in the US. Our courses include Java, JavaFX, Python, Go, Modern C++, and Docker and Kubernetes. We're the authors of 9 textbooks on software programming, and we have 2 books on JavaFX that you see here. For our latest book, the one on top is called The Definitive Guide to Modern Java Clients with JavaFX 17. And Gail and I contributed a chapter on JavaFX fundamentals, as well as a chapter on packaging options for JavaFX executables. And the other book that you see here below is JavaFX Rich Client Programming on the NetBeans platform. Gail and I are also both Java champions and Oracle ACE members. Okay, this is our agenda for today. We want to begin by discussing why you would want to do Java and JavaFX on mobile to develop applications. Our demo today is TiltMaze, which uses the device's accelerometer. And along the way, we're going to show you how we designed the game, how we used FXML and the scene builder drag and drop tool from Gluon, and then how we used GraalVM to generate the native images for iOS and Android. You'll also learn how to use the various frameworks like Gluon Substrate, the Gluon FX plugin, and the Gluon Attach library. And then we'll also talk about JavaFX binding techniques and how we use the JavaFX animation class to implement the animation loop for the game. We'll also show you how we did the deployments of our game to both iOS and Android, and this game is in the app stores. At the end of the session today, I'll do a summary, and then we'll address the questions that you can post in the comment sections during our Q&A session. Okay, let's start with why would you want to do Java and JavaFX on mobile? Well, a critical goal here is to write once and install everywhere, and to have platform-independent source code. Now, today, you're not going to see any Objective-C code or any Swift code for iOS. Everything is going to be in modern Java and JavaFX. And the idea is to have one code base that we can then deploy to iOS and Android targets. The design approach that we used the Gluon tools and libraries and frameworks. And we're also using Oracle's GraalVM framework to let us build native images for iOS and Android. The other advantage of using JavaFX are listed here. JavaFX is a mature and well-maintained UI toolkit, and the targets for the Gluon and GraalVM that we talked about to build the native images allow you to target iOS and Android, of course, but also Mac, Linux, and Windows, and also embedded for the Raspberry Pi, and even the Mac with the Apple M1 chip. Now, JavaFX is worth doing because you have a rich set of UI controls and charts to visualize, and JavaFX has a screen graph metaphor that lets you manipulate the nodes in your UI. There's an FXML loader to separate the view from the model and the controller, and there's also a JavaFX concurrency library to support asynchronous background execution to keep your UI responsive. JavaFX also has observable properties to support binding and maintain program state. And remember, JavaFX is Java APIs. That means you can use streams, lambdas, and all the new Java features, such as records and the enhanced switch syntax. And JavaFX is maintained by Gluon in partnership with Oracle. Gluon also has commercial support with long-term LTS releases. Okay, here's our demo for today. This is our Tilt Maze Labyrinth. This is available in the stores. So it's a mobile game that you can install from either the Apple App Store or Google Play. So on the left here on the screen, you see the game when it first comes up. And on the right-hand side, you see a sample of moving the ball while you're playing the game. Now, the game is simple enough. You navigate a rolling ball through a maze within the given time allotment while avoiding strategically placed holes that you see here. And as you lift the phone or the tablet, the application reads the device's accelerometer sensor and moves the ball based on the reading. The slider, which is labeled as novice and expert, controls how fast the ball rolls and the time allotment for completing the maze. And as your skill improves with our game, you can challenge your dexterity by making the ball movements more sensitive while simultaneously decreasing the time allotment. Okay, I'm going to hand it off to Gail now, and she's going to show you where Tilt Maze is up on the app stores and also run the game for you.
Okay. Hi, everyone. Tilt Maze is our proof of concept mobile application. So we want the idea of going from having an idea to getting it actually in the app stores. And we chose to use the accelerometer so we could show how to access a hardware part of your device in a device agnostic way. So first I'm going to show you the App Store. So here it is in the Google Play App Store. And it's also available for the Apple App Store. So you can see you have both an iPhone form and an iPad form. And there's ways that you can tell what device you're running on so you can scale the maze appropriately. Okay, so what sorts of features does this game use? So we use the Gluon Mobile, which is for mobile-friendly controls. It's not a requirement, and it depends on your use case. We also use the accelerometer in an animation loop, and we'll talk about the animation loop later. We use collision detection. So before I go any further, let me just show you what this looks like playing. Now, I'm going to go ahead and bring this up on the desktop. And a couple caveats here. One is that we simulate an accelerometer when we're running on the desktop. And we do that because the edit, compile, run cycle is much faster on the desktop than it takes to create a native image for the different mobile targets, to install it on the target, and then to test it out. So we do some high-level testing on the desktop. And what we do is we ask, is there accelerometer service available? And if not, we install a mouse event that will track the mouse. So it looks like this. Now, it's going to be a little bit different running on the desktop versus holding the device in your hand. It's actually much easier on the desktop because you could kind of control how fast things go. But the object is to go to one of the target green holes. That's for the win. It tells you how many seconds it took you. And along the way, it does collision detection with these barriers as well as these trap holes. So if you fall into a trap hole, you lose. Let me just show you what that looks like. Oh no, fell into a hole.
And it's a lot easier to do this with the mouse like Gail's doing than it is holding the phone and moving it around. You'll see when you play it.
Okay, so what we're going to emphasize partially in this talk are these controls: the button, the slider, which can, if expert means you have less time to complete the maze, and also the accelerometer becomes more sensitive, so it's harder to avoid the trap holes. Novice means you get a lot of time and the accelerometer readings are damped down, so you have more control. The code is available on GitHub, and we'll post the link at the end of the talk. Also, we have the notes that you can download from our website that have all these live links in it. Okay, let's go back to the notes. And
okay, so let's talk about how we designed Tilt Maze. And what we did was we started with a markup language in JavaFX called FXML. And then we used a tool from Gluon called Scene Builder. And what Scene Builder does is it generates the FXML code for you. Now, there's two reasons why you want to use FXML when you're designing UIs like this. One is that it helps you separate the view from the model and the controller, and that's always a good idea when you're designing UIs. The other reason why you want to use FXML is that when you start up a JavaFX application, an FXML loader will parse the FXML file, instantiate the controls, and call setters to configure them. And that means that you don't have to write as much JavaFX code, because a lot of it is generated for you by Scene Builder. So Scene Builder that you'll see in a minute here is a complete drag and drop tool that has controls that you can drag onto a palette rather, and then you can configure them. And also Scene Builder lets you customize your own controls, and you can load your own font libraries. So for Tilt Maze, we used the Glisten UI controls from Gluon that were skinned for mobile. And on the JavaFX side, we used a pane to draw the maze that you saw, and a stack pane for the layout, as well as a HBox and VBox. And Gail's going to show you now some FXML and Scene Builder.
okay, first we're going to go to our IDE, and we're going to look at the FXML that describes this view. And it's down here somewhere. Here we go. So you can see FXML is XML markup language with its own specific rules. Let's bring up the game so we can kind of get a concurrent look. I want to show you the button, and this is the start stop game button here, and that's defined here. And you can see that we can use properties to configure it. And again, this is FXML. There's a slider, which is this progress speed slider that we discussed earlier. And then we have a stack pane here. And in the stack pane, we have embedded a progress indicator and a label. And the label displays the seconds. So while this is pretty clear from this, it's not very visual. And if you want to use a design tool, then there's a free tool called Scene Builder from Gluon that you can use to do drag and drop and design your view that way. So to get to Scene Builder, there's two ways we can do that. Either here, it will bring up Scene Builder in our editor, but it kind of is a little bit of a smaller real estate. So to get more real estate, you can use the drop down. And at the bottom down here, it says open in Scene Builder. And we can bring up Scene Builder with our FXML. Now, you're going to notice right away, it doesn't look a whole lot like our application. And that's because we do a lot of the color selection, and we actually build the maze after the application starts running. So we have it's a static list of barriers and holes that we build, but it's still nice to see. So over here, we have a whole list of controls that we can choose from. For example, here's the Gluon list of tools that are especially skinned for mobile targets. And you can just select them and drop them into your palette. You can, down here in the hierarchy, you can see detailed views. So here's the button, which corresponds to this button. And over here in the inspector window, we have, we can configure it. So let's look at similarly, the slider is here, and we can configure it here. And so the minimum is 0.5 and it goes to a maximum of 2. And that's the range of the both the seconds and how sensitive the accelerometer readings will be. And then finally, we indicated that we had a stack pane. You saw in the FXML source, there was a progress indicator, and then on top of that, the label. So we have a progress indicator, which is a circular progress indicator. And what we do is when you start the game, the progress indicator empties out, kind of like an hourglass empties out. So instead of filling up a task, it empties out. It just seemed more reflective of what the game is doing. And then the label indicates how many seconds we have left. So this is a real basic overview of Scene Builder. So let's quit Scene Builder. And now we'll go back to, oh, one thing I have to show you. And that is, okay, so remember Paul told you that the FXML loader instantiates the controls that you define in your FXML, but you can access them with the FXID flag. And here's the slider, here's the maze, here's our label, and here's the progress bar, and the button. Oh no, here's the label, another label. And then this is the button. And so we can access these. Now, we don't instantiate them ourselves, as Paul indicated, the FXML loader does. So you won't see any code that has a new. It's all done for you. And any configuration that you put in the FXML file will do that for you as well. Okay, let's go back to the notes.
Great. Okay, let's talk about the accelerometer, which is a key point of our game here, since that's what's being used when we play the game. Okay, so the accelerometer on a device is a sensor that measures velocity changes in 3 dimensions, and that would be horizontally, vertically, and up and down movements that include the effects of gravity. Now, the accelerometer is very sensitive. In fact, it's difficult to hold the phone or tablet in your hand, remaining as motionless as possible and not see any readings change. So what we do is we sample the accelerometer readings in an animation loop, and we use the X and Y values to update an object in the JavaFX XY coordinate space. Now, the coordinate system for the accelerometer matches the JavaFX coordinate system for the x-axis, because values increase from left to right. But for the y-axis, the accelerometer coordinate system is opposite. So in JavaFX, the origin for the y-axis is at the top, and numbers increase as you move towards the bottom of the screen. This means that we have to multiply the y-axis readings in our code by -1 so that it conforms to the JavaFX coordinate system. Okay, Gail's going to talk about scaling and using mouse events for mobile devices and also the accelerometer, so I'll turn it back over to her.
Okay, so obviously we're targeting mobile devices, but even though mobile devices are generally rectangular shaped things, they vary in size, their aspect ratio varies. And so we wanted to scale the maze to make it as large as we could, but to keep it within its aspect ratio constant. And also, we also wanted to limit it being displayed in portrait mode orientation only, so that it wouldn't change and rearrange itself if you happen to reorient your device. We wanted it to run on both tablets as well as mobile phones, and there's quite a bit of variation. And as we indicated earlier, we did a small program just to learn how the accelerometer works, and that's how we discovered how sensitive it was, where we just displayed the readings. But once we figured out, okay, we think we know how the accelerometer worked, it made sense to be able to run this on the desktop to do initial debugging with the UI components. So I'm going to show you a little bit about the initializing the accelerometer service and detecting whether it's there, so we can use the mouse events. So let's go back to our IDE, and we're going to go to okay, so here's code that we run at the beginning, and we say, hey, do we have accelerometer service? And all the, so Gluon has something called the attach library, where you can access various underlying hardware devices. And they're all, it's pretty standard how you access. So this, you do a create. And if the accelerometer service exists, great, we get it. Otherwise, in this program, what we do is we create a mouse event that just reads where the current mouse is, and we store that in our current X and current Y variables. We also set an event handler that allows you to start the game by pressing on the ball itself. And I'll show you how that works. So the other thing is, around a little bit here. So for scaling, there's ways where you can say, hey, how big is my device? So our border is the outside border of the maze. And so we just have some code in there that scales the maze as well as centers it how we want it to look in the program. Okay, so let's go to
Okay, let's talk about GraalVM, a very important part of what we did here. GraalVM is this is an architectural diagram of GraalVM from the GraalVM team at Oracle. So let's talk about what it is and why you would want to use it. So GraalVM is a high-performance JDK distribution from Oracle that's designed to accelerate the execution of applications that are written in Java and other JVM languages. GraalVM allows compiling Java applications ahead of time, that's called AOT, into native executables for faster startup time and lower memory overhead. Now, GraalVM is very important these days in the Java space because what people are doing is they're taking their Java applications and using GraalVM to create native executables, and then then you can put those into Docker to containerize your Java application and then manage it in the cloud with Kubernetes. Of course, what we're doing with GraalVM is we're using it to create targets for iOS and Android. Now, the inputs to GraalVM that you see here on the diagram, the inputs are a Java application, any libraries, dependent libraries that you have, the JDK, and a Substrate VM. And the GraalVM itself performs several steps that you see here, points to analysis, run initializations, and heap snapshotting. The outputs of GraalVM are the ahead-of-time compilation of the code to the text section, along with an image heap in the data section of the native executable. And note that GraalVM can generate native executables for Linux, Windows, and Mac OS. Okay, here you see another diagram, and these are all the pieces that you need to build a modern JavaFX application using the Gluon Substrate framework and GraalVM from Oracle. First, let's talk about Gluon Substrate in the middle. This is a framework from Gluon that leverages not only the GraalVM native images, but also JavaFX modules and support libraries. So you can see below the Substrate block, the Java JDK, OpenJDK, and the JavaFX SDK, and then of course GraalVM down below there to do the AOT compilation. And then the Substrate tool bundles all the required supporting native libraries for the target system. And then there's also a Maven plugin that allows you to perform any configuration you want to do in a POM XML file. Now, in the lower right there, Gluon Mobile UI Access, that is device access and is provided by the Gluon Attach library that we'll discuss shortly. Yes. Now, remember, with GraalVM, the native application does not need a Java VM at runtime. So users do not have to install a JVM as a separate step. Instead, you use the native image AOT image that GraalVM will generate for you. And native image apps can run on iOS devices, which of course prohibit any JVM applications from running. Okay, so let's take a look at the attach library right now, which we just talked about a second ago. Okay, so the Gluon Attach library lets you access hardware features on your mobile devices in a platform agnostic way. This library makes available all the storage systems, accelerometers, of course, any screen details, and GPS as well, and more in a device-independent fashion. Note that the Gluon attach library is open source and licensed for free under the GPL license. And to use it, you just have to add a dependency to your build script. Now, with Gluon attach, you can what you do is you treat hardware devices as what we call services. After you create a service, there are APIs to enable the service with the call to the start method. Then you can access the service itself with methods that are service dependent, and then you can disable your service with a call to stop. Currently, Gluon attach supports 30 different services, including what you see here, the accelerometer, audio and video, the battery, the barcode scanner, compass, and so forth. But of course, there's a lot more, and Gail's going to show you some of that right now in the supported services.
Okay, so we're going to this.
No, we don't want to do that right now.
Okay, so here, this is Gluon's website, Gluon documentation, where they discuss the attach library, how to get started with it. They have a great sample section, and here is a list of the full list of supported services currently. But as you can see, they add things to it all the time. Okay, so it's great. There's a description of the service, takes you to the Java doc if you want to read more. And as I said, there's samples that you can see. So we are using the accelerometer. So there you go. Okay. All right. So at this point, we hope that you may be curious about, oh, okay, I might like to write a mobile app myself using JavaFX and the Gluon plugin and GraalVM. So how do I get started? So we put together some resources for you. And the first two resources here is a Gluon start page that will build a starter template Maven project for you. You can configure it and then download it. And I'm going to show you that. And then this is the GraalVM JDK. It's specific to Gluon. It's based on the community edition, and you'll also need to download that. So I'm going to go ahead and show you these things on the web at the moment. Here's the Gluon start page. So you can configure it. You can choose which version of JavaFX you want. You can use different JavaFX modules, but you don't have to know a whole lot about it, because when you choose the Gluon features, it will grab the correct modules for you. So for Tilt Maze, we chose Glisten to give the nice skinning for the mobile targets. It's not required. We just decided to use it for this one. So if you want it, you choose it. And then this Afterburner is a minimalist dependency injection, which I find very convenient. And we use that also in Tilt Maze. There is a connect feature that lets you load data resources. There's a maps library for cross-device map interfacing. There's also a Cloud Link, a service from Gluon that provides various features such as data in-app billing, things like that. And down at the bottom is the attach library, and it gives you display, lifecycle status bar, and storage by default. But what we did is we added then the accelerometer. And what that will do is add the Gluon library to access the accelerometer and create the correct dependency for you. And you'll notice that the FXML module was chosen when I clicked on Glisten Afterburner. But again, you can use the FXML without the Afterburner. Okay, so once you've configured this to the way you think you want it, you can preview the project. It's a Maven project. You have all the source that it generated for you. The README file is convenient because it gives you the Maven commands for building your particular targets. So the one that I used when I showed you Tilt Maze running on the desktop was simply this. It created an executable that ran on the JVM using Hotspot, and it was a JIT compiler. But you can also target your machine, and you can target Android, iOS, and then it tells you which JavaFX modules you're using and which Gluon features. And of course, it generates a POM file for you. So this is where the dependencies are put in, so that you don't have, so for example, you don't have to download JavaFX separately. It will grab it for you, and you just have to have the GraalVM JDK. And again, the Gluon documentations tells you how to configure that. And then very, very important and very convenient are the profiles that exist in the POM file. And the profiles describe both Android and iOS targets. And what this does behind the scenes is this is how it grabs all the native libraries that it will need to create the native image based on the profile that you select. So once you've gone through and said, okay, yeah, this looks like a good starting point, you click on Generate Project. It will create a zip file and download it to your desktop machine. You can unzip it and open it up into your IDE of choice. The GraalVM JDK is here. And again, you choose the correct target. So when I'm doing development on the Mac, I use the Darwin target either for Java 11 or Java 17. When I use Android, I need the Linux one, and so that's there too. And I'll talk more about it, but this is where you go to grab the correct target. Okay, so let's go back to here. Two more resources for you. There's Gluon has a bunch of samples on GitHub. So let's show you that. And when I was first using JavaFX in the Gluon space, I downloaded this whole tree and looked at all the code and taught myself a lot about how everything works. There's some very simple examples here. The hello ones are pretty simple, but there's also more complicated ones that show you how you might want to use Cloud Link to get notifications and store user data, and do logins using password, user ID, password, or other like LinkedIn or Google IDs to log in. So it's very convenient for all things mobile. And then finally, we wrote a set of tutorials, how to create mobile apps with JavaFX. This is on Fuji. It's in 3 parts, and we used Tilt Maze as the example. And the first part, we just talk about kind of the stuff we're talking about today, but all the JavaFX, how to use the accelerometer, what are the different things involved. That looks familiar. How we scale it, mouse and performance. Now, part 2, we talk about what you need in the different targets. What do you need for an iOS app, how to develop it, and what do you need for an Android app, how to develop it. The third part is, okay, I have this cool app. It's running on both kinds of hardware, Android and iOS. How do I get it to the respective app stores? And this steps you through, the third part steps you through that. Okay, so let's go back to
the notes here.
Notes.
Okay, back to me here. Let's talk about JavaFX property binding now. Okay, in JavaFX, a property is a Java field that's wrapped in an observable class. That means that you'll be notified when a property updates. So in JavaFX, you can write listeners that will call back to a method when a property changes, or you can use a simpler way, a simpler approach by invoking the bind method in JavaFX to update properties. And the bind technique is much more succinct and less error-prone than writing listeners. Property binding is also a convenient way to maintain game state when property values depend on other properties or settings. And there is a JavaFX bindings library that lets you build complex expressions that define the state of your properties. And these These property bindings are already pre-built for you in the bindings library. So in Tilt Maze, we use JavaFX binding for the start and stop button, the timer label, the speed slider, and the progress indicator. And Gail's going to show you some of the code for the property binding that we have in our application.
Okay, so let's go there. Oops. Okay, let's bring up our game. Okay, so this is the accelerator button, the start stop button that we use to run the game and stop the game. And the text changes when it's running. It says stop game. And when you stop it, then it says start game. And we accomplish that with this binding method, this binding statement that calls the when method, which is generates a ternary expression. So when this thing is true, then it's stop game, otherwise start game. And so one statement then will control the correct behavior of the text of our button. So that makes it really convenient. Move this over so I can go to another example. Okay, so also while the game is running, we disable the slider property. So we want to be able to change it just fine when the game is not running, but as soon as we start the game, you'll see it it's not completely disappeared, but it fades out a lot so you can barely see it. It's disabled and we can't change anything about it. So that is accomplished with the disable property, and it's bind to whether or not the animation timer loop is running. And talk about the animation timer loop in a little bit. Okay, what else we have is 16, the timer label text property, and that is that's the text property that displays how many seconds we have left. We also do that with binding. So this is a property that takes a string, but it depends on another property that is a double. So the bindings.format lets us turn it into a string, but also says that it's a floating point number. We want to display 4 places, including the decimal point, and 1 place to the right of the decimal point. And so then you get this. So as the seconds changes, then this timer automatically gets updated. And as you can see, the progress indicator gets updated too, and that is also bound to the time seconds. But this time we do a divide by the start time, and this gives us the, so the time seconds things decrements. So this allows us to have the progress indicator go from being filled to empty. And the progress indicator, the progress property is a property that goes, it's a double that goes between 0 and 1, where 1, it's completely filled, and 0, it is empty. So when it times out, it will go all the way down to 0, and the blue line disappears. Okay, so let's go back to notes.
Okay, next we want to talk about the JavaFX animation loop. This is the heart of our Tilt Maze game. Is an animation loop which we implemented with the JavaFX animation timer class. Now, in JavaFX, animation timer is a public abstract class, and that means that you have to extend this class and then override the public abstract handle method, which has 1 argument representing the current time. When running, the system actually will invoke the animation timer's handle method for you once per frame, and the system provides the current time in nanoseconds to this handle method as an argument. And so it's inside this handle method is where you want to perform the tasks that, that need to be performed for the game. Now, in Tilt Maze, the animation timer controls the actions in the game environment. So inside our handle method, what we do is we read the accelerometer and update the maze with the readings. We also perform collision detection and with the barriers and the holes, and we check to make sure that the timer has, to see if the timer has expired. The animation loop also updates the JavaFX time seconds property that Gail mentioned a minute ago, according to the observed frame rate. And if time is elapsed, we handle the work for the timeout and then reset the game.
Okay, so I am going to show you some. Wait, is it here? Yeah.
Yeah, actually, it's me.
Oh.
Oh, next slide. Okay.
No.
Oh. Okay. Oh, yeah, okay. Gail's going to talk about that. Right. Sorry.
Okay, so I have a lot of things to show you.
We fumbled the handoff.
Yeah. We're not going to talk about football, though. What?
No,
okay.
It was yesterday.
Okay, so the first thing I'm going to show you is the start-stop button, which I've shown you multiple times. This is what controls the animation timer loop. And when it starts, we start the animation loop. So when the game is active, the animation loop is running. But the other thing is that if you have an accelerometer, then the accelerometer service is started. So you can't read the values from the accelerometer unless you have started the service. And that's what this does here. And when you stop it, you stop the service. Now we have to check for null because like on the desktop, there is no accelerometer, and that's where we read the mouse instead. Okay, so let's talk about animation a little bit. So we're going to go here. And this is the game timer class, which extends animation timer. Now, before I talk about animation timer, just briefly, there's 3 approaches to perform animation in JavaFX. The first approach is using high-level transitions, and these are very easy to use. For example, and it allows you to manipulate one or more properties on a node that's in the scene graph. So, for example, the translate transition allows you to move a node, you rotate it. The fade transition allows you to fade in or out. And the scale transition allows you to resize a node. And you can control the time of that, the values where they go to and from, and you can put transitions in a sequence or have them execute all at once by doing a parallel transition. But it's limited to the nodes that you have in your scene graph. A second way is with something called timeline with keyframes and key values. And there you can use other properties, not just the properties associated with the node, to manipulate them. And they can be underlying properties that then are bound to things that are visible. And then finally, the third way, the timeline with keyframes and key values is more low level. And then the third way is with the animation timer class that you see here. And this lets you define work in an animation loop. As Paul indicated, you need to override the method, the handle method. So I'm going to go to that right now. And you see we have the override annotation, and we do a couple things. We update the frame rate, and we had to do some manipulations with the frame rate because we found that the frame rate really varied depending on the device. There was one of our iPads, I think, had a frame rate of 120 frames per second. Normally, it's 60 frames per second. So we wanted to make it consistent because if it was 120, then the timer would go down twice as fast. So we wanted to normalize that so everything was about equivalent to the 50 of 60 frames per second. Okay, so what does update do? Update basically does the whole game in terms of controlling the UI. So let's go look at that for a second. And you've seen the game. You've seen the game run. So the first thing we do is we decrement the time seconds, and remember that that's it's a JavaFX property, and it controls how much time we have left in our maze. So if we've run out of time, the game is over. We do the timeout. Otherwise, we read the accelerometer, And we've already done the create and we've already done the start. So now we can actually access the accelerometer with the get X and get Y. We ignore Z because we don't, as Paul said, we don't take into account the up and down motion, just left to right or up and down, forward, backward. It's kind of hard to do this orientation. And we figure out what the changes is. If we don't have an accelerometer, instead we read where the mouse is. Okay, so let's go down here. And we have a specific order that we do things. The first thing we check is if we fell into a hole. That's the first thing we check. So we don't do any other collision detection just with a hole. So either the game is over at this point if you fell into a hole. Either you fell into a target hole, yay, you won, or you fell into a trap hole, boo, you lost. So that's what happens here. And then if we're okay with that, we do the barrier detection. And that's where we update the ball if it's moving. So let's go down to sorry, I have to. This is okay. So the translate property is what causes a node to move in the scene graph. So we update the ball's translate X property if there hasn't been a collision. So if based on the accelerometer readings, if it changes and we didn't run to a wall, we move the ball either left or right. And we also check the, we update the translate Y, the up and down for the ball if we haven't run into a wall. And if there is a change, then what we do is so just show you this. You can see how a line is drawn as the ball moves. So that's what happens here. If we have moved the ball with the translate X or translate Y or both, we do a new line 2, which draws that blue line that traces the path of the ball throughout the game. Okay.
Great. Okay, let's talk about how we generated everything with Maven Commands for not only running and testing on the desktop, but also to iOS and Android. So here, what you see is what we did for initial testing. We used the Maven Gluon FX:run command to compile, link, and create a JVM image that runs on our desktop. And to do this, GraalVM uses its just-in-time JIT compiler. The other commands that you would see here would build and create a native image to run on the desktop. And in this case, GraalVM would use its AOT compiler. Note that you can run all of these Maven commands that you see here on Mac, Linux, and Windows. And of course, for Tilt Maze, we don't need to build a native image for the desktop because we're not targeting that device. Now, what we did target, of course, was iOS and Android. So Gail's going to show you the commands to set that up and deploy it to those targets.
Okay, this is going to be a really quick overview of something that will, in reality, take a lot longer. But let's talk about iOS target setup first. So to have to target your mobile app for iOS, you need a Mac. You need the Xcode development tool, and you'll need an Apple developer license, which is $99 a year. And that includes Apple signing certificates, both one signing certificate that allows you to install the application on your own device, connected device, and a separate certificate for uploading your app to the Apple Connect site, which gets you into on your way into the App Store. It has to go through certain testing and approval. The other thing you need are the native libraries. And again, the Gluon documentation tells you exactly what you need. And the GraalVM JDK that we discussed, where to get it and how to download it. You set your environment variable GraalVM home to the GraalVM JDK. And that's for the Maven plugins to find the correct Java. You can use Homebrew to install any native libraries that you might need. Now, when you target the iOS, the Gluon plugin generates default configurations for specific I/O settings. It gives you a default info.plist, which is an XML file, and I'm going to show that to you right now. So up here in your tree, and you typically don't have to change it that much, but you probably will have to make some changes to it. So in the Maven build, it puts it in the target library. So you want to move it over to the source so that it doesn't regenerate it every time and your changes are kept. So what changes did we make? Well, we commented out the orientation for landscape left, landscape right, and portrait upside down, and only allow the portrait orientation. And that's so that it doesn't reorient while you're playing the game. And we do that for the iPad as well. And then you have to tell Apple that, yes, you're going to be using the accelerometer. So you do that there. And that's the only configuration changes we made for that. We also, Gluon will give you a set of default icons, and you probably want to change that. So we used Inkscape, which is a open source drawing tool, to create our icon. This is what it looks like, and this is the 1024 by 1024, and there's websites where you can give it this image and it will generate the other sizes. So you can see over here, there's lots of different sizes, and they have to have specific file names. Okay, let's go back to notes. Okay, so when I showed you the POM file or the README file, these commands were in there. So specifically for iOS, you say that you're using the iOS profile, and that will cause the correct native libraries to get pulled in. The build command does both a compile and a link, and the package command creates an IPA file that you can submit to test flight for beta testing. For testing locally, what you can do is run the install command, and that will install it. You hook up your device through a USB to your Mac and do install, and install will put it on your device. You leave it hooked up to and run native run, and what that allows you to do is to see any system.out.print lines or logging output from logging files when you're running it on the connected device. So that's really convenient for debugging. Okay, so what about Android? Now, Android, you need a Linux machine. So you can either use a native Linux box, you can use a virtual Linux machine, which is what we use, but there's caveats with that. And I think I would recommend the first thing, the Linux box. Native Linux box. With the virtual Linux, you have to make sure you give it enough disk space and enough memory, and you can get weird errors if you don't. Or you could use GitHub Actions, which I know other people have used it. I myself haven't used that, but that's a viable option as well. You need the Android development tools, but you don't have to download those. The Gluon plugin will download the tools that you need. You need the GraalVM JDK for Linux that I discussed earlier, and Android uses Java signing. Again, you want to create an icon and feature configuration. So for Android has something called the Android manifest.fxml. And again, you say, yes, I want to use the accelerometer. And here we limit the orientation to portrait mode. And we also created equivalent icons for that. Let's go back to notes. So this is similar to the iOS, the Android native target. You specify profile Android, and again, it's the same commands. Build will do the compile and link, and package will create an APK file, which is the Android packaged native image. And again, if you since I was using a local Linux box, I hooked up my Android phone to this Mac with USB, but I accessed it through the Linux virtual box. And so it's the same thing. You can install it and native run, and the native run will give you output from logging. And you can also use the ADB debugger for Android in that case.
Okay, let's summarize what you learned today in our session. We showed you how to use modern Java and JavaFX to do mobile development. And we had one code base that we could write and maintain for both iOS and Android targets. We implemented a Tilt Maze demo app using the Accelerometer. And then you learned about these frameworks and libraries, including GraalVM to create the native images, as well as the Gluon Substrate, the plugin, and the attach library for what we did with Tilt Maze. We also showed you the benefits of using modern Java and JavaFX to do UI design. And you also learned a little bit about FXML and the scene builder tool. And along the way, we showed you property bindings and the bind method, which is so nice and convenient to use, and then how we implemented the animation loop for the Tilt Maze game. Okay, well, we're good. We've got a few minutes left here. We want to thank everybody for attending our session. This is our contact info, which includes our email addresses and our Twitter handles. And the source code for all of everything that we talked about today on Tilt Maze is available on GitHub. And the notes, a PDF of what we talked about in this session is available up on our website. So you'll be able to, you can download that PDF on the homepage of our website, and then you can click on the links and go through the things that we talked about. Okay, so
I'm looking at the comments. I don't know if it's all of them, but it says Linux is required because there's no GraalVM on Windows. Actually, there is GraalVM for Windows, but you need Linux to grab all the Android native libraries and the target for Android. You can use GraalVM for Windows and create a native application that will run on Windows. But as I said earlier, our target was mobile applications. So it wasn't the desktop for Mac, for Linux, or for Windows, but that is a viable target.
By the way, it looks like we have some folks here from Germany, Brazil, and London, so that's great. I'd like to say hi for everybody there. Let's see, how could anything for Apple be free? No comment, I guess.
Well, the Xcode is free, but the developer's license is $99 a year.
$99.
But it doesn't cost you anything to put the application in the store for either Google Play or Apple App Store. But you do have to jump through some hoops to follow all their rules in terms of age appropriateness, data privacy, and things like that. Fortunately, this example doesn't use or ask for any user data, and it's pretty kid friendly. My grandnephew, who is 9, absolutely loves to play it and kept reporting what his score was to me every few minutes when he visited.
And he got better and better at it as he used it too. Okay. So we hope that you liked what we did here, and this was a lot of fun putting this together. And of course, anytime you can work in the Java space and have fun is always a good thing. Are there any more questions here? Android device license is still $25
I don't
a lifetime.
Okay, it's been a while, but I don't remember paying anything. So.
Yeah, I don't think we paid anything.
Okay, that might be a different framework that I'm not familiar with it, but as we said, the advantages of using JavaFX is that you get to use Java and the whole ecosystem that goes along with Java.
Right.
So that was a question about Unity 3D or Unreal Engine?
Yes.
Yeah, these are gaming engines, I think, so they have a lot of rich APIs.
Oh, so if
gaming engines.
Okay, so if somebody is interested in a gaming engine, there's something called FXGL that is a gaming engine specifically for JavaFX. So for where you are a participant as a avatar in a game, that's things like that. So this was way simpler than a gaming engine would require.
Yeah, I think the gaming engine is generally tries to offer a richer experience. So the gaming engine would have been built on top of FX, I believe, in order to achieve the same effects. But I kind of think that building a gaming engine in FX would be slightly easier because it already does a lot of things for you, like the animation, correct? As long as you keep building the frames.
Okay.
Yeah, okay. So here's our, real quick, here's our website, and you can see the at the very top of our page here is today's session and everything. And down below where Gail's highlighted that, download the slide deck. That's where you can get the PDF file for today's session and have everything there, plus the links.
Has all the links. The links are live, so.
Okay, top of the hour here.
Are we? We can still take a few questions if there's
anything else?
Comments or questions.
Okay, thank you, Sebastian. Yep, thanks, Mike. We had fun doing this, and it was fun showing it to you as well.
And so we have actually another game on the app stores called
Wordish.
No, that's not in the app stores.
Oh no, yeah, you're right.
Mini golf.
Mini golf, right?
So it is a 9-hole golf that you can go through. And actually, my son designed it way back when we were writing a book on JavaFX script, and we hired him to write a nice example, and he did. But then I had to translate it from JavaFX script into modern JavaFX, and that was the first game that we put into the store. And then we have another example application you can find on GitHub, but it's not in the stores because it's not really ready for it. But it's called Wordish. It's based on the New York Times Wordle game, and it shows some really, really cool features of JavaFX skinning and CSS for to reflect state of objects. So that's great.
Yeah, I actually have a latency model I wrote in FX, and it's probably an example of like how not to write an FX application.
So you're not going to show us your code today?
It's open source on GitHub. You can actually go and look at it if you so dare. And you don't want to be blind at the end of the session. I think I mentioned this to you before, Gail, but yes, having a professional actually look at it and say ugh and do something with it would be kind of fun sometimes, because it actually is an interesting model, because it shows you.
So you're hiring me online here. It's pretty good.
Yes, exactly, and you'll get the same open source rate that I got.
Oh, I see. Okay.
Actually, I'll double it. I'll give you this one.
Yeah.
Oh, we have another question here. Yeah, we had another question here. When is JavaFX better than a progressive web app?
Well, with JavaFX, the combination of JavaFX and GraalVM, you can build a native image. So the execution is going to be much faster, and the image itself, all the work that the GraalVM team has done to create images that are small, has really paid off. I mean, it pays off in the world of Docker, but it also pays off in the world of building apps that are execute well. So that's just my. I don't know if you want to add anything.
Yeah, no, that's about right.
Progressive web app.
Okay. Any other questions or anything?
Oh, and with just one other thing, if you're thinking of a mobile app and you're the app that I showed you here is just one screen, one view. Most apps are multi-view. Think of things like Twitter, formerly known as X, formerly known as Twitter, or other applications on the web. There's multiple views, and so the Gluon Glisten controls help you manage views. And so back when I was learning that, I wrote an application that allowed people to input their blood pressure, and that was in a scrollable component. But then you could go and look and see it charted, and you could also go and look and see averages over a certain period of time using different charts, and the different views. The controls, Gluon controls, let you manage that in a really nice way. So what I showed you today doesn't really highlight what mobile controls can do, because it was more just simple. It's one view, that's it. And we were going for the hardware access in a device agnostic way. That was our goal.
Awesome.
Okay.
I don't know if we're just having people starting to drop off now. I guess I probably want to go on to the next wonderful session, which has already been underway.
Okay.
Thank
you, Kirk, for moderating us.
Oh yeah, it was a lot of really hard work. You can see I broke into this spot here. So
yes, indeed,
really difficult. But you know, yeah, thanks for inviting me to moderate you.
Yeah, always a pleasure having you with us.
And yeah, so thank you for watching the session with Paul and Gail, and I get a round of applause here. And,
okay, thank you.
Great session. And
thank you.
Okay, thanks everybody. Thanks for coming. We'll see you another time.
Yeah. Okay.